Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hi, everybody. Welcome to Wednesday night math night. I am so excited to be here with you on this Wednesday. I look forward to Wednesdays with you guys. So welcome to Wednesday night math night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And we just love what we get to do, which is help you feel more competent and confident in your math skills. So we love what we get to do here. And so, yeah, we're here every Wednesday. Join us every Wednesday with your popcorn or your snack or your cookies or your bowl of ice cream or whatever it is. And we love being here. Part of what we do here on Wednesdays is we like to tailor it to what you need. And so I like to make sure that we are, doing problems that are tailored to the test that you're taking, the needs that you have. So I always have a next week section. You can always find me on Facebook. But I always like to give you a choice to let me know what are you struggling with. So as we're working through problems, let me know in the comment section, maybe some things that you would like to see me go over in the upcoming weeks so that I can better serve you. Hello, Jada. Hello, Reggie. Hello, Intifada. I really should have asked you how to say your name when we did tutoring. I also do tutoring through the Learning Liaisons, and I wish I would have asked you how to say your name so I could pronounce it correctly. Hi, Marcus, Marco. It is good to see some familiar faces. I love it. So let me know in the comment box where you're from, what test are you prepping for, and our get to know you question, what month is your birthday in? That question comes from the fact that my little one's birthday is tomorrow. So we are celebrating his birthday. He is very excited about his birthday. I feel like it's like the first birthday he's really understood like what's happening. So that's super exciting. So what month is your birthday in? My birthday month is June. I was actually born on Flag Day. So that's super fun. But let me know where you're from, what test are you prepping for, and what month is your birthday in. Any February birthdays so that we can say happy birthday to you. Yeah. And I am from Central Florida also. I didn't say that. Your birthday, oh, I thought you said your birthday was on Saturday, but your birthday is in October and you are prepping for the EC6 on Saturday. Pre-K through 3, pre-K mathematics, and your May birthday. Jada, what part of Florida are you from? We've got a couple of people from Florida in here. I love it. Like I said, I'm from Central Florida. I grew up here, raised here, born and raised here. We moved to North Carolina for like a little bit, and then we came back. Orange Park, Florida. Awesome. Zephyr Hills. Very cool. Man, we've got some Florida people. Hello, Florida friends. Y'all, we experienced a little cold snap the last couple of weeks. I'm sad that is gone and that we are back to hot Florida. That is not, I don't love it. All right, let's go ahead and get started with our first problem. And yeah, let's get started with our first problem and let me know in the comment box what you are struggling with. Ask me questions while we're here tonight. That is why we are here, y'all. Ask me all the questions, and we will go ahead and get started. A student is solving an addition problem using the make a 10 strategy. The student's work for the first problem can be seen below. If the student follows the same process as he did for the first problem, which of the following will be the student's answer for the second problem? Which of the following will be the student's answer for the second problem? All right, so this is a really fascinating question because they are not asking for the correct answer. They are asking for what the student's answer would be if they followed the same pattern. And that is really hard. This is a student error analysis problem. And so we're looking for student error analysis. Pretty much any math test you take nowadays, unless you're taking the GK, any instructional math test that you take is probably going to have student error analysis on it. And so we are looking for the student's error and then to replicate it. So the student is solving addition problems using the make a 10 strategy. Mind you, this is going to be a pre-K through 3, K through 6 kind of problem. High school people, I promise we will get to stuff for you in a little bit. The student's work for the first problem can be seen below. So we're looking to follow the same process. So this student took 8 plus 7 and expanded it to 6 plus 2 and 4 plus 3. 8 is the same thing as 6 plus 2. 7 is the same thing as 4 plus 3. And then it looks like the student used the commutative property. And I'm going to write that here. Not that you need to know it for this problem, commutative. But you need to understand what it does. It means that we can switch those add-ins in any order and then we can add. So they switched these two add-ins. So instead of 6 plus 2 plus 4, they did 6 plus 4 plus 2 plus 3. Then the student did 6 plus 4 is 10. And in our head, we know that we should have done 2 plus 3 would be 5. But it looks like the student made the 10. And then what did they do after they made that 10? They just pulled the add-in from up here to down here after they made the 10 and then got 17. So if they use the same process for this next one, 6 is the same thing as 4 plus 2. It really doesn't matter what you do here. Plus 9 is the same thing as 6 plus 3, right? And then I can rearrange 4 plus 2 plus 6 plus, nope. 4 plus 6 plus 2 plus 3, because then this makes a 10. But then after I make my 10, you notice it doesn't really matter what this looked like, because really I made my 10 and then pulled that second addend down. And so that's going to end up giving me 19 as my answer, even though you and I both know that 6 plus 9 is actually 15. So it doesn't matter how you broke this into that make a 10 strategy. It really doesn't, because as long as you made a 10 and then pulled that second addend down, that you created that error that student made. It's a really interesting question, isn't it? All right, let's go ahead and move on to the next problem. If you have questions while we are working, don't hesitate to ask me in the comment box, okay? Let's go ahead and move on to the next problem. Miss Pettit has been working on oral counting with her students. She is teaching them that there are patterns in the way that number names are typically developed. She wants them to begin to pick up on those patterns. Which of the following number names least reflects the typical pattern in the way number names are constructed in the base 10 system? 12, 19, 37, or 80? All right, so we're working on oral counting. Again, this is a pre-K through 3, K through 6 problem. These two problems were specifically requested by a friend of mine who is taking the test here on Friday. So we will get to some more complex problems for my people who are not taking pre-K through 3 or K through 6, but I wanted to make sure I addressed that since this person is taking their test on Friday. She is teaching them that there are patterns in the way that number names are typically developed. She wants them to begin to pick up on those patterns. However, we all know the English language is not necessarily following a pattern. We know that when we have ESOL students who come in and they try to learn the language, we know that when we look at the patterns of, like, when we're teaching spelling patterns, we're like, well, it's I before E except after C. Like, all of that happens, and it happens in math too. So which of the following number names least reflects the typical pattern in which names are constructed? 12, 19, 37, or 80. So when we think about our number system, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then we have 11 and 12, which really don't give us any clue as to what that number is. But then we have 13, a 3-teen, 14, a teen with a 4, 15, a teen with a 5, 16, 17, 18, 19. All of those follow that pattern. And then 20 is a 2 and a 0, 21, 22, 23. They sound like the number that we're producing. So 19 is a 9 and a teen. 30, and this is so mathematically not correct, like in the way that I'm speaking this, but I'm trying to relate the English language to math. 37, a 3 and a 7. 80, an 8 and a 0. 12 does not follow that typical pattern. In fact, 12 is the correct answer, but neither does 11. 11 doesn't follow that pattern either. But every other number in our number system follows that pattern for the most part, right? And so 11 and 12 can be really difficult for our little ones to conceptualize when they start to represent those numbers. In fact, it can also be hard for them to conceptualize when they start to learn how to just rote count. My little one, who's almost three tomorrow, struggles with 11 and 12. In fact, at one point, 11 was his favorite number, and I think it's because it just didn't follow the pattern. Like, he could count to 10, and then he would say 11-teen, 12-teen, 13, 14, 15, and that makes sense when he is trying to follow that patterning system. And so he came up with 11-teen because that's what makes sense in his brain. And so if you think about that, for some of our students who struggle, that is definitely going to be an area of struggle for them, is looking at that pattern because it doesn't follow the pattern. Questions? Questions about that? All right, let's go ahead and move on to the next problem. Marie has a rectangular patio that she decides to expand to make space for more furniture. The upgraded patio will have a length and width each double their previous measures. If the area of the current patio is 300 square feet, how many times bigger will the upgraded patio be? How many times bigger will the upgraded patio be? Half times, 2 times, 4 times, or 8 times? So when we think about this problem, we want to look at the rectangular patio and what we're doing to it. And if they don't give me dimensions, I will make dimensions up just so I can visually see this. So I'm going to create my rectangular patio. And she wants to expand it. So we're going to take this patio and we're going to expand it, right? Okay. And this patio, the upgraded patio, will have a length and width that are each double their previous measures. So if this is 10 and this is 20, and I like to pick easy numbers if I'm going to double it so I can see what's going on, then 10 times 2 is 20 and 20 times 2 is 40, right? So 20 times 40 equals, and 10 times 20 equals. What does that look like? So 10 times 20 is 200, and 20 times 40 is 800. If the area of the current patio is 300 square feet, I didn't pay attention to that, but quite frankly, it doesn't matter that I didn't pay attention to it, because the concept of scaling is going to be the same no matter what the dimensions or the area is. I'll show you that in a minute. How many times bigger will the upgraded patio be? How many times bigger is 800 than 200? 200 times what equals 800? 200 times 4. So the upgraded area of the patio is going to be 4 times bigger than the original. And you're probably thinking to yourself, Amy, I don't understand why. Because if the length and the width are double their previous measures, why wouldn't the area just be double? Because area is square measurements and volume is cubic measurements. And so when I double the linear measurement of my length and my width, then I'm going to, if I'm multiplying times 2, my linear measurement, I need to square that to figure out what scale my area is going to be, which is 4 times. Now, if scale measurement is difficult for you, that's okay, because you can absolutely come up with your own measurements. It doesn't matter if it's 300 square feet. If my original rectangle was 300 square feet, I can do 10 and 30. 10 times 30 is 300. And then my new one would be 10 times 2 is 20. 30 times 2 is 60. 20 times 60 is 1200. It's still 4 times the area. So it doesn't matter that I missed that 300, because it's still going to scale in the same proportion that the other one would. Questions about that? All right, let's go ahead and move on to the next problem. So Marie still has a rectangular shaped something, but this time Marie has a rectangular prism shaped greenhouse that she wants to expand to make room for more plants. The upgraded garden will have a length, a width, and a height that are each 4 times their previous measure. If the volume of the current garden is 30 feet cubed, how many times bigger will the upgraded garden be? In this case, again, if you need to, you can always create measurements that are going to equal 30, and then you can create a new garden, right? But if we know that when we scale something, my area is going to be squared, my volume is going to be cubed, then I can take this 4 times and cube it, and it will give me how many times the upgraded garden will be. So I can do 4 times 4 times 4, which is 64. So the new garden will be 64 times, and I didn't even do a whole lot of work to figure that out, right? I didn't even do a whole lot of work to figure that out. So can I create measurements that help me figure all of that out? I absolutely can. But if I understand scale factoring at its finest, then it allows me to save some time to be able to buy some time in another problem, right? All right, let's move on to problem number 4. The measurements of a rectangle are shown to the right. What is the closest measurement of the perimeter of this rectangle? The measurements of a rectangle are shown to the right. What is the closest measurement of the perimeter of this rectangle? So this is a fun one. We have the measurements of this rectangle, which are 6, and then the diagonal is 10. And then if that's 6, then I know that this is 6. And they are asking for the closest measurement of the perimeter. Well, I know that perimeter is what? And that is for everybody. Perimeter is the distance around the shape, right? So if I walk around the shape from here, then it would be here to here to here, right? So I have 6 and 6. And then I need to figure out what this side is, because this line is not part of that perimeter. It's just the exterior. Well, how am I going to figure out the missing side of the rectangle? Well, I have to recognize that I have a triangle here. And so and it's actually a right triangle. And if I have a right triangle, then I know I can use the Pythagorean theorem to solve for that missing piece. So that said, if this side is 6, then I have 6 squared plus blank squared equals 10 squared. Why didn't I do 6 squared plus 10 squared equals blank squared? Because the hypotenuse is always C, and the hypotenuse is always across from that 90-degree angle. So I have 36 plus b squared equals 100. Subtract 36 from both sides. I have b squared equals 100 minus 36 is 64. Square root both sides. B equals 8. So that means that this side is 8 and this side is 8. And then I can just do 8 plus 8 plus 6 plus 6, which equals 28. So I don't normally do this, but I just had a question pop through the comments. So normally people, when they ask questions or comments in the comment box, they're like, I want a problem about triangles. And then I have to like go research or come up with one. But somebody just asked a very specific question. So we are actually going to go rogue, and I'm going to write that question out here, and we're going to solve it right here because that is what we're here for. So the question says, a rectangle has a length that is, this is a great problem for everyone, twice the size of its width. If the perimeter of the rectangle is 48 inches, what is the area? What a great question. This combines our understanding of geometry with algebraic like translation of algebraic translation of words. So a rectangle, I'm going to draw my rectangle, has a length. So I'm going to label these length and width. A length that is. Whenever I see is, I think equals. So length is twice the size of the width. 2 times W. Twice the size of the width. Perimeter of the rectangle is 48. So I know that L plus W equals 48 because remember, we go all the way around the shape for our perimeter, right? So L plus W is going to give me 48. Now, how do I figure that out if I have two variables? Well, this is a key piece of information. I can actually replace, I can substitute my L's for 2 W's because L is the same thing as 2 W's. Length is 2W. So I can replace the L with 2W. Each L equals 2 W's. Plus another W, plus another W, plus 48. All I did was substitute those out. So now I can add 2W plus 2W plus 1W plus 1W is how many W's? 6 W's equals 48. And simple math, what's done to the variable? I undo. So I'm going to divide both sides by 6. And W equals 8. But that's not what they asked for. And I guarantee you, if this was a multiple choice question, one of those answers would be 8. They asked, what is the area? So if W equals 8, what does length equal? Length is twice the size. So length is going to be 16. Which now means I know that area equals length times width. So 16 times 8 equals 128. 128. That was a good question, y'all. All right, let's go ahead and go on to the next question. Wait, how did I get 16? Okay, I'll go back. I got 16 because the words told me, I love that you asked that question. The length is twice the size of the width. So because I solved for my width and I got 8, I know that 2 times 8 is 16. twice of 8, 2 times width is 16. I can also plug 8 in for W right here. And 2 times 8 is 16. So then that length equals 16. You are welcome, Intifada. You are welcome. Jada, I hope that answered your question. If it didn't, let me know and I will reword that and try to explain it a little better. Got it. Good. I'm glad. You know, when you guys ask questions, it makes my job so much more interesting because sometimes I just feel like I'm staring at a computer screen. I mean, I am. But it just makes it feel like we're like in my living room a little bit more or like at a coffee shop. Like it just makes it feel a little bit more interactive. So thank you for commenting. Thank you for asking questions. It makes it more interesting for me. I appreciate it. All right. A unique greenhouse is being built and is shown below. The developers are trying to determine how much cubic air the structure can hold. How many feet of cubic air can fit inside the greenhouse? How many feet of cubic air can fit inside the greenhouse? All right, so here's what I need everybody to get. Volume of a prism equals, you know, I just love when my iPad decides to disconnect. That's total sarcasm. It drives me nuts. I really thought we were going to like make it to the end of the session today without it happening, but that didn't happen. So we'll just reconnect here. Present, share screen, show a window, done. All right. So volume of a prism equals area of the base times the height of the prism. Now, your base is the thing that shows up twice, that is identical. In this case, this is your base. And here is the identical base. That's your base. And technically, this is your height. Because the height is the distance between your two bases. The height is the distance between the two bases. So this is my area, or that is my base, and this is my height. Whereas a lot of people are going to misconstrue this, and they're going to think that this is the height and this is the base, because that's what the greenhouse is sitting on. So don't misunderstand that. Now, I know that my volume formula is going to be area of the base times 60. 60 is my height, so I'm going to plug that in right away. I'm going to get that right out of the way, out the gate. Now, I can look at this base in a variety of different ways. If you have the area of a hexagon memorized, good for you. I do not. I don't like to hold formulas in my brain that I don't need. So that's just not something that I hold in my brain. That said, I do know what the area of a trapezoid is. I also know what the area of a triangle is. So there's a variety of ways I can do this. I can do area of a trapezoid and then multiply that times 2, because this is my first trapezoid and this is my second trapezoid. Or I can do, I know that in a regular hexagon, I have 6 triangles that are all the same size. And as a result of those triangles being the same size, I know that I could find the area of one of those triangles and then multiply it times 6. So whichever way you want to do it, you're going to get the same answer, but I'm going to do trapezoids. So the area of a trapezoid equals base 1 plus base 2 divided by 2 times the height of the trapezoid. So base 1 is going to be 12. Base 2 is going to be 20 divided by 2 plus height of the trapezoid. This trapezoid has a height of 32 divided by 2. This trapezoid has a height of 32 divided by 2. How do I know that? So the height is 6. No, not 6. Sorry, 16. Goodness. How do I know that? Because from the top of the trapezoid, or from the top of the hexagon to the bottom of the hexagon is 32. And so if I cut that in half, then that's going to be that perpendicular height of the trapezoid, which is 16. So 12 plus 20 is 32. 32, there goes my iPad again. Third time's the charm, y'all, right? Third time's the charm. 32 divided by 2 is 16. And then 16 times 16 is 256. So then I can just take that and plop it right in here to my volume formula. So 256 times 60 is 15,360. Why did I get that wrong? Base 1 plus base 2 divided by 2 times height. 12 plus 20 is 32. Divided by 2 is 16 times 16 is 256 times 60, 15,360. Interesting. Well, 15,360 is the right answer. So there's that. All right. Sometimes that happens when I create problems from my head. And that's exactly what just happened tonight. I had a question regarding how to solve the area of odd shapes. I sent an email of the picture of an example question I had. Okay. So, oh my goodness, Marco, thank you. Y'all, this just proves that I am not perfect. Thank you. I'm like, what is going on? Because then I did it with triangles in my head and I was like, this is not right. Okay, so it's because I only did one trapezoid. This is the area of one trapezoid. That's not the area of a hexagon. I have to do 256 times 2 because there's 2 trapezoids, which equals 256 times 2. $256 times 2 is 512 times 60 is 30,720. Okay, that's still not the right answer. Okay, so here's what I actually think the problem is. Okay, first of all, tired brain, I didn't do 2 trapezoids, so proof that even the math expert can make a mistake. But number 2, here's the problem. I actually created a shape. I created this problem. I'm pretty sure I created a shape that is actually mathematically impossible. So when we look at this, I'm pretty sure the triangles in a perfect hexagon should be equilateral triangles. Yes. And what I created are not equilateral triangles. So when we look at this hexagon, so you should know that a perfect hexagon creates equilateral triangles. So when we create these equilateral triangles, that means that all of these sides should theoretically be 12, right? And if all of those are 12, then that means that this distance right here is not 20, it's actually 24. And so if that's actually 24, then that's going to skew our results. And so then we would have 12. Let me just figure out if that was the problem. 12 plus 24 divided by 2 times 16 times 2 times 60. That actually solves the problem right there. So I arbitrarily picked numbers thinking that it wouldn't matter, but it actually did matter because a perfect hexagon or a regular hexagon creates 6 equilateral triangles. So when I picked that number 20 in the middle, I actually created an impossible shape like that. You literally can't create a perfect or a regular hexagon with the dimensions that I provided. And so that was the problem. So the process I used is how you would find the prism. So like the whole process was correct. I just created an impossible shape. That's all. You are welcome. I am human. I do make mistakes. And I am 100% willing to admit when I do make mistakes. And thank goodness for Marco, who was like, yo, you need to do 256 times 2 because it's not just one trapezoid, it's 2 trapezoids. So we are a community here and we just solved that problem together. So if you use triangles, you got the right answer because you actually were using the shape that was supposed to be created. On that note, let's just move on to problem 6 and hope that there's all correct answers for problem number 6. James drives 12 miles per hour slower than Gavin. With 5 more hours of driving time, James travels a total of 400 miles compared to Gavin, who travels 195 miles. At approximately what speed is James driving? So James is driving 12 miles per hour slower than Gavin, but he has 5 more hours of driving time. So James drives a total of 400 miles compared to Gavin, who travels 195 miles. What speed is James driving? So when I see speed and distance and all of that, my brain immediately goes to distance equals rate times time. Distance equals rate times time. And so we have James and we have Gavin. So James drives 12 miles per hour slower than Gavin. So, and James travels 400 miles. So distance equals rate. His rate is 12 miles per hour slower than Gavin. So Gavin minus 12. And his time is 5 more hours than Gavin. So 5 plus G. Gavin's distance is 195. And he has a rate and a time. Right? He has a rate and a time. So, but this should be Gavin's rate and this should be Gavin's time. I know I solved this. 12 miles per hour slower than Gavin. We're going to call this T. Because T is consistent, right? So like So now I am going to, I'm actually going to replace this with R. So R is Gavin's rate and T is Gavin's time, right? So now that makes a little bit more sense. R is Gavin's rate and T is Gavin's time. But what I want to do is I want to replace one of these with something else so that I can substitute and have one variable, just like we did in the other problem. So I'm going to divide both sides by T. So rate equals 195 divided by T. I'm going to plug this in for R right here. So 400 equals 195 divided by T minus 12 times 5 plus T. This should look like a quadratic formula for my high school people, right? So now I can FOIL this out. So 400 equals 195 times 5. 975 divided by T plus 195 divided by T times T. Those T's are going to cancel, so that's just 195 minus 60 minus 12T. You following? If you're taking an elementary test, you don't need to follow this. 195 minus 60 is 135. So 400 equals 975 divided by T plus 135 minus 12T. I'm going to move everything over to the left side of my problem, and I'm going to make some of this a little smaller so that I have more room. So I'm going to move everything over to the left. So that gives me negative 975 divided by T minus 135 plus 12T plus 400 equals 0. 400 minus 135 is 265. So negative 975 divided by T plus 265 plus 12T equals 0. Multiply everything by T so that I can get rid of that T in the denominator. So I end up with negative 975 plus 265T plus 12T squared equals 0. Y'all, this is such a big problem. We're going to move all of this like way up here so that I can finish this. So that is 12T squared plus 265T minus 975 equals 0. Now I'm going to use the quadratic formula to figure out what T is. So negative B plus or minus the square root of B squared minus 4 times A times C all over 2A. Woo, y'all. This is quite the problem. 265 times 265, negative 265 plus or minus the square root of 70,225. 4 times 12 times 975. That's going to end up being a positive because a negative times a negative is a positive. So negative 265 plus or minus the square root of 117.25 divided by 24. Let's go ahead and square root that. So that equals negative 265 plus or minus 342.1 divided by 24. But let's keep in mind that we're solving for T, right? And so I can't have a negative time in this problem. So I'm not going to do negative 265 minus 342. But what I am going to do is negative 265 plus 342. Then divide that by 24. So my time is going to be 3.21. And keep in mind, that is Gavin's time because Gavin was the one that we were using as the base. So Gavin's time is 3.21. James's time is going to be 3.21 plus 5. So James's speed is going to be, now we have to solve for Gavin's speed by plugging 3.21 into Gavin's formula. So we're going to go back to Gavin. So we have 195 equals rate times time. Divide both sides by 3.21. So 195. So Gavin's speed is 60.75, which means that James's speed is going to be that minus 12, which is approximately 49 miles per hour. My brain, y'all. That was quite the problem. And I started just blowing through the math part of that just so we could get to the answer. If there is anything in there that did not make sense to you and you're a high school person taking this test, this was a lot thicker of a problem than they would typically offer on a test because it just takes a lot of time. But it's not out of the question. All right. I actually have a bonus question today. Like there's some other problems that we can solve, but this problem is just fun. And so we're going to do this problem because it offers a lot of like skills that could be on a test. So this is really going to be more of like a lesson. We've not done this before on Math Wednesday night, but this was a problem that one of my math teachers had on his board. And I was like, oh, that's a fun problem. So let's look at it and then we'll solve it together. How far will the spider walk on the outside of this box from A to E? From A to E. All right. So A, B, C, D, E. From A to E. So when we look at this problem, we need to consider that we know that this is a cube. And if you were taking a test, it would tell you that this, or a rectangular prism. This is a rectangular prism. So we know that all of the corners or edges are 90 degrees. This combines our understanding of rectangular prisms with Pythagorean theorem and distances. So I know that this side is 4. So then this side is going to be 4. This side is going to be 4. And so is this side, right? And then I know that this is, it just is disconnected again. Try again. Okay. So then I also know that this side is 5. So that means that this side is 5 and this side is 5, right? And then I also know that this side is 3. So then this side is 3 and this side is 3 and this side is 3. So knowing all of that and taking all of that into consideration, it helps us when we're trying to solve this problem. So I'm going to go ahead and erase all of that just because it junks up the image for us. So I need to figure out what this distance is, but that creates a triangle. If this side is 2, then this is also 2. Not because it looks like 2, but because this is 4, which means that this is 4, which means that this entire thing is 4. So I have a triangle that has 2 and 5, and I'm looking for this question mark. Pythagorean theorem, a squared plus b squared equals c squared. 4 plus 25 equals c squared. So c is going to equal the square root of 29. So A, B, equals the square root of 29. I also need BC, I need CD, and I need DE to figure out the distance of this spider. Let's look at BC. Now I have this distance. Well, if this is 3, then this is 3, and this is also 3. So now I have 3, 4. So 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. C squared equals 25. So C equals 5 because I can square root both. Are you seeing the pattern that we're working with? So now we're going to do CD. I know that this bottom is 5 because this top is 5. 3, 5. 3 squared plus 5 squared equals C squared. You notice that we're finding the hypotenuse of all of these triangles. So C is going to equal the square root of 34. And our last triangle is going to be 3 and 2.5. So 3 squared plus 2.5 squared equals C squared. All of that is going to be 9 plus 6.25, which is 15.25, square root of that. And then you add all of those together. Y'all, was that not the most fun problem you've done in a while? That was pretty much the most fun problem I've done in a while. And so I wanted to share it with you, but it offers a lot of different, concepts in one problem. So yeah, I'm going to turn it back over to Dr. A. Let me know if you have any questions in the question box. I look forward to seeing you all next week. Next week is Valentine's week. Friday's Valentine's Day. So we'll have a Valentine's themed get to know you question. Maybe do you like the box of chocolates? What's your favorite chocolate in the box of chocolates? That'll be our question next week. I'm going to turn it back over to Dr. A. It was so good to see you. Thank you for asking all the questions. Thank you for helping me, and I will see you next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.